Hi friends, today we are going to read or learn about the geometric progression. In the last session, we learned about arithmetic progression. So we understood that arithmetic progressions are a, the basically the differences of two consecutive numbers will be same. So for example, if there will be two numbers and there is given some number sequence of number, then the difference of those sequence of number will be same. But in case of the geometric progression, it's the sequence of ratio. So basically, sequence of ratio, I mean, if I divide 4 with a 2, then it will be 2. If we divide 8 with 4, it will be 2. If we divide 16 with 8, it will be 2. And if we divide 32 with 16, it will be 2. So 2 is the ratio of division of every next consecutive number. So suppose you will have a given us a number of this kind of number series, and if someone asks you that what will be the uh, 78th number, what will be the 200th number, so basically we can calculate up to the 456 number, but if it is a very large point, then we cannot keep multiplying that 2. Like if I multiply 32 with a 2, then it will be 64. 64 will be the next number. In same way, if I divide 64 with the 2, then it will be 128. That will be the next number. Like that, if we keep multiplying, sorry, if we keep multiplying, sorry, we'll have to just multiply with the 2 to each consecutive number, and it will be the next number. So 32 multiply by 2 will be 64. 64 multiply by 2, 128. Same way, 128 multiply by 2 will be the next number. In that way, if suppose someone asks what will be the 78th number, then you cannot keep multiplying 2 every time. So there should be some formula, there should be some definition. In same way, someone can ask you that what will be the sum of the consecutive 13 number. So like a 2, 4, 8, 16, 32, 64, 128, like that up to 30. If we take the number up to 30, and what will be the sum of them, then up again for the sum also we cannot keep adding these numbers. If it is a very large, then it's a very difficult. So because these are a sequential number, and we know that there is one sequence which is the ratio of these numbers are always same, so we can have some formula for both finding the nth number or finding the sum of the nth number. Correct. Now we understand what is the uh, geometric progression. Here in example, you see just one sample example it has been given, that in this example, like first number is a, second number is a of r, a multiplied by r, third number is a r square, fourth number like this. The nth number will be a r to power n minus 1, and this is the nth number, right? And if you divide ar with a, then then what will be the output? R. The ratio of ar and r, a will be a crossed, and it will be r. Same way, if you divide a of r square from ar, then again it will be r. Same way, if you go on keep dividing each consecutive next number with the previous number, then r will be the. So if these r are coming, which means it a geometric progression. Okay, this is the geometric progression. Whenever we see any sequence of this kind of number in an exam anywhere, then we have to understand this is a geometric progression, and how we will able to solve it with the help of the formula. So in a formula, it has given proofs of the formula also. There are theorem. We won't go to that theorems. We can understand, get it from anywhere. So for example, nth term. If someone asks you that if some given sequence of number is in a GP, then what will be the nth number? Like I was saying, like what will be the 78th number here? Like what will be the 78th number? So to get that 78th number, we have a formula called a of n is equal to r into a of n minus 1. Here a of n is nth number, that is the particular term, whichever number will be there on nth position. Then r is the ratio of the each consecutive number, that common ratio, a of n, that nth number minus n. So this formula we have to just remember. Same way, to get the sum up to the nth number, we have a formula s of n is equal to a into r to the power n minus 1 divided by r minus 1. Just we have to remember this formula. Correct. Okay. So there are definitions of this formula and all we will find anywhere in the books. We will more focus on the how it works. So basically, just a few things we have to remember that suppose the sequence of number which is given, if it is for the infinite, then the formula will be like this. I mean, so if we have to calculate the sum up to the infinite, then formula will be different. We'll see from the problems. We just understood that what is the geometric progression. Let's see some one and two problems, and based on that, we can solve a lot of different problems. So look at the pattern. So see this pattern. There is the one, there is the 1 by 2, there is the 1 by 4, 1 by 8, 1 by 16, 1 by 32, 1 by 64, 1 by 28. This is the sequence. Do you think it is in a geometric progression? This is a geometric progression. See, if we divide 1 by 2 from 1, then it will be 1 by 2. If we divide 1 by 4 from 1 by 2, then it will be 1 by 2 again. If we divide 1 by 8 from 1 by 4, it will be 1 by 2. If we divide 1 by 16 from 1 by 8, it will be again 1 by 2. Same way, we can see that the ratio of every next division, ratio of the every previous and next number is 1 by 2, which means there is the common ratio between the every numbers, which is 1 by 2, which means it is a geometric progression. Correct. So we understood that what is the geometric progression.